Let's talk about experimental design. Let's still think about that experiment where we're studying the effectiveness of Advil to treat headaches. So let's imagine we have 25 subjects who are going to be given the Advil in our treatment group or test group, and then 25 subjects who are going to be given a placebo in our control group. There are three components of a good statistical study that I'd like to talk about. Replication. What replication is being able to repeat the experiment on multiple subjects so that we can actually tell what's happening. If I just give one person Advil, the headache is either going to get better or it's not, and I'll never know if that occurred by chance or if the treatment was effective. So the larger the sample size is in both groups, the more information I will get. So replication is simply repeating the process. One of the themes in our course is going to be that the larger the sample, the better the data we get. The more people I give this treatment to, the better I'll be able to determine the effectiveness of Advil as a headache reliever. The next component of a good statistical study is called blinding. Blinding is where either the participant or the person giving the treatment doesn't know which one of the groups they're in. In a single blind study, the participant doesn't know. Which group they're in. And I think we can kind of guess why we wouldn't want to know, the participants to know which group they're in. If I know I'm getting the actual treatment, I might subconsciously influence the results, right? I might have a psychosomatic response where my headache goes away. This is literally called the placebo effect, where when you give someone the placebo, their symptoms still abate because psychologically they think it's supposed to go away. So in a single blind study, we rule out the placebo effect from being able to affect the study. In a double blind study, neither the participant nor the researcher they interact with know which group they're in. So this requires more than one researcher because ultimately someone has to know what group they're in, but the person they interact with doesn't have to know whether they're getting a placebo or a treatment. In the double-blind study, we rule out the researcher, the person they interact with, from being able to influence the study, either subconsciously or consciously. It ensures that both groups are treated absolutely the same. The double-blind study is superior to the single-blind study. The single-blind study is often more economical because it requires less researchers. And then the final component of a good study I want to talk about is randomness. When we're choosing people to be in our treatment group or our placebo group, we want to do that randomly as to make both groups mirror the population as much as possible, to use chance to help us get good representation in both groups. We want to randomly assign people to both the treatment group and the control group. There might also be other factors in the study that we want to use randomness to help us assign as to not influence the data. This idea of randomness takes away researcher bias, right? I'm not putting certain people in the control group. I used randomness so that my groups mirror the sample and then also the sample mirrors the population.